Okay, everybody, let me let's introduce this evening's or this afternoon's program. So I think we have a really exciting program ahead of us today. Our speaker is Dr. Paul Carr. Many of us know him from the work that he's done with IRAS. He also has done significant work in the scientific and the religious fields. He has a PhD in physics from Brandeis. He had been at MIT before that. He led the component technology branch at the Rome laboratory, where he's currently Emeritus. He's done basic work on surface acoustic waves and has numerous publications in that area. He also studied religion at Harvard with Paul Tillich, Boston University School of Theology, Andover Newton, and Boston College. He's had multiple different Templeton Awards. He's also published, he's done a lot of work championing climate change, has been an IRAS Academic Fellow Award in 2018. He wrote his book, one of his books is Beauty in Science and Spirit. What he's going to do tonight is he's going to talk to us about, the title of his talk is Nothing at the Cosmic Beginning. And in this talk, he's going to talk a lot about the idea of something from nothing, the fact that this is maybe not scriptural. He'll also relate this into some of Einstein's work, some of Alan Guth's work, and some other work that I think will be very interesting. So with that, I'm going to turn the program over to our speaker. And please take it away, Paul. Paul, you're muted. Paul, could you unmute? We're not hearing you at all.
Okay, you can hopefully hear me now.
Yeah, we can hear you, but you need to share screen.
Right, now I'm going to share my screen.
Perfect.
Get to my title slide. There we go. Nothing at the cosmic beginning.
And can you put in presenter mode so that it's bigger for all of us?
Presenter mode, yes. Okay, nothing at the cosmic beginning. Now, this talk was inspired by Science and the Ever Creator by Theologian Thomas Oord. And the first two slides are just a quick overview of his problems with creation out of nothing. He says, creatio ex nihilo implies that creating is not necessarily a divine attribute. This God may or may not create. 2, creation ex nihilo implies that God has controlling power, including the ability to create something from nothing instantly. A God with controlling power like that ought to use that ability to prevent evil. No explicit scriptural support for creatio ex nihilo, creation from nothing. Water covered the face of the deep, as in the first chapter of Genesis. Long ago, by God's word, the heavens came into being and earth was formed out of water by means of water. That's in Peter. 4, it fails to motivate ecological concern and creation care. In other words, if God can do everything, why should we do anything to save our planet? Mainly, it has no explicit scriptural support and makes little metaphysical sense. Out of nothing comes nothing. As he says, Tom Oord believes that the Gnostic theologian in the 2nd century proposed creatio nihilo. That's where it came from. So I'm going to focus on modern cosmology, and there was something at the beginning of modern cosmology. So an outline of my talk in our last century, and I'm going to start with 1920, finding our place in the Milky Way galaxy, and keep in mind that the diameter of the Milky Way galaxy is 0.1 million light years. In 1927, George Lemaitre's hot Big Bang theory, based on Einstein's general relativity theory, which was first published in 1915. 1964, discovery of the cool fossil radiation nose or whisper of the Big Bang. And it occurred 13.8 billion years ago. And just compare that now, just keep in mind what a huge increase and how our vision of the size of the universe has changed from a 0.1 million light year diameter of our Milky Way, which was pretty much our view of the universe in 1920, to 1964, where the size of the universe, or the beginning of the universe, was 13.8 billion years ago. In 1985, the Hubble telescope gave us images, and I'll be showing those to you, that formed 2 billion years after the beginning. 2021, cosmologist Alan Guth noted that the laws of physics existed before any universe. And finally, some recent photographs from the James Webb Space Technology, images of galaxies 0.35 billion years after the beginning. Amazing progress in the last century. So in 1920, this is a photograph of astronomer Harlow Shapley, who discovered our place in the Milky Way. We're not the center as was earlier thought, and we're about roughly halfway out. You can see our sun, which is the center of our galaxy, which has a diameter of 0.1 million light years in diameter. Father George Lemaitre, inspired by Einstein's general relativity theory, published his hot Big Bang theory in 1927. For him, the universe began with a tiny hot fireball or mathematical singularity. This is illustrated in the right graphically, of course. It was formulated mathematically, but and he also predicted the Hubble's discovery of an expanding universe. That was part of his hot expanding Big Bang. He was a Catholic priest and physicist. He took Hubble's research and postulated that the universe was expanding from a fixed point in space-time. Lemaitre insisted that he had nothing to do with his religious beliefs, but was purely a scientific postulation. Here's a letter that I submitted and published in the American Physical Society news, not with a bang, but a whisper, and I'm going to explain why I think that's a better metaphor for our present universe. But in this article, I give a little bit of the history of the Big Bang, and particularly the fact that in 1969, and by the way, generally speaking, Lemaitre's proposal was not taken seriously. There was no experimental support for it. In addition, the astronomer Fred Hoyle, who was an atheist, thought it was a little bit too much like the Bible, and he actually, in a radio program in 1945, talked about the Big Bang as, he coined the term the Big Bang to deride Lemaitre's prediction, which he had no use for. However, in 1964, these astronomers, Penzias and Wilson, discovered the fossil microwave afterglow of Lemaitre's Big Bang. It was this microwave noise was part of what I call the whispering universe. You know, all experimentalists, of which I am one, need to reduce the noise level of their detection system, and they reduced the thermal noise by using cryogenic temperatures for their receiver, and so they got rid of thermal noise, and yet there was noise coming through their antenna they just couldn't get rid of, and it turned out that there were pigeons whom that they said deposit a white dielectric substance on their antenna. They thought that that substance might be the cause of the noise. They washed it off and it didn't go away. And they really didn't know what this noise was all about. And fortunately, a few miles away at Princeton, Dickey and Peebles, who was Dickey's graduate student, and some other scientists like Gamow, had computed that hot Big Bang of Lemaitre, when it expanded, if it expanded as it expanded to fill the universe, it would have cooled. And I'll tell you the temperature that we've just measured, how cold it actually was. It expanded and cooled, and that it would be manifested by noise, basically radiation noise. And you know, you may remember your FM sets or your old televisions when you tuned between stations, you get a sort of a, and to me, that is you may well have heard the cosmic black body radiation noise, and it has a spectrum as shown here as measured by the Cosmic Radiation Explorer satellite, which was launched to measure the spectrum. Penzias and Willcombe were working out here at wavelengths of the order of a centimeter or several inches, maybe the same wavelength in your microwave oven. But you can see most of the energy is at one millimeter. The theoretical red curve is Planck's black body radiation theory with a temperature of minus 270 degrees C, which is 2.74 degrees above the absolute zero of temperature. And this curve and the amazing, wonderful fit that you show is regarded as the best experimental confirmation of Planck's black body radiation theory. Well, here is our present hot to cool, which I call the whispering cosmos. I find that whisper is a better metaphor for the hiss you may have heard on your radio. It all started with a hot Big Bang as hypothesized and predicted by Lemaitre. And then there was a period of very rapid expansion. The vertical dimension is the size of the universe. And you can see here is our expanding universe first discovered by Hubble. Now it's hot to cool. And the color coding, white hot is extremely hot, billions of degrees. But as the universe expanded, it cooled as shown. And you can see red is cooler than the yellow. So as the universe particles started condensing out, just like when hot steam from your tea kettle hits a cold surface, you see these droplets. Well, as the radiation cooled, we started to get fundamental particles. We got the first atomic nuclei, which are basically hard protons, the hard nucleus of hydrogen. And then it cooled enough so that the hydrogen atoms formed. In other words, the electrons in this hot plasma joined up with the protons, and we had hydrogen. And at this point, the radiation could escape. And this is what Penzias and Wilson measured, initially discovered. So I'm going to give you some experimental verification of this. This is first I'm going to show you another plot of the black body radiation. And then I'm going to show you a Hubble photograph of the galaxies in the early universe that took place. That photograph is 2 billion years after the beginning. To calibrate you, our Earth came into existence about 10.5 existence after the beginning, and the age of our universe is at 13.8 billion years. So I'm going to show you some photographs. First, a little more detail on this cosmic black body radiation. Basically, the whispering cosmos from cooler temperatures 0.3 million years after the beginning. That's this plot here on the left. And then on the right, the Hubble telescope deep field. This is a plot of as I told you, the average temperature of the cosmic black body radiation is about 2.7 degrees above absolute zero. However, there are fluctuations in that temperature, from quantum fluctuations in the early universe. And these fluctuations are very small, about 1 part in 10,000. But this is the image of the universe. These fluctuations in the universe 0.3 million years after the beginning. The image of temperature fluctuations was measured by the Wilkinson microwave anisotropy probe. The cooler regions seeded the stars and the galaxies. And I'll emphasize later, you notice that there's clustering here. Here clustering of some of the hotter areas and some of the cooler areas are clustered. This is not a uniform random distribution of fluctuations, and there's a lot of information that we'll be unpacking for you in the distribution of the temperature. But this is a photograph that I first saw at a Star Island conference in 1995, where my respondent Chris Corbally co-organized, and to tell you the truth, it blew my mind. I think all of us are used to seeing, as I was, you look up in the sky and you see moon and then maybe some planets and stars. And the idea that a telescope could image light coming 12 billion light years away, 2 billion years after the beginning. And the universe, it was at that point in time, was filled with galaxies. It blew my mind, and it still does. Well, we've continued on getting close to the beginning. This is recent James Webb telescope images of the first galaxies, and this unit 1 was galaxy. This is enlargement here. This is the little. It is a very small galaxy in the infrared. As the universe expands, the wavelength gets stretched. Very small galaxy. It came from this area of the sky over here, which is expanded here, and then either further back in time, another galaxy here, another even smaller galaxy, 0.35 billion years after the beginning. These galaxies are only a few percent of the size of our Milky Way. So this data will enable us to learn more about galaxy formation in the early universe, and this data is only a few months old. So where does this fit in? Well, I told you about the cosmic black body radiation about 0.3 million after the beginning, and then I showed you the Hubble telephone 2 million. Well, the James Webb galaxies are closer to the beginning, as shown by that arrow. The purpose of this slide, this is a Sloan Digital Sky Survey, and it's just it only goes back to about as you can see here, about 7 billion years after the beginning. And the main purpose of this slide is to show you that the non-uniformities in the cosmic black body radiation, remember I pointed the clustering, there's clustering, that same clustering occurs in the galaxies. You can see the galaxies are also not uniformly distributed. There's clustering. There's places where there's a small amount of galaxies and a higher density. It turns out that gravity has amplified the clustering of the non-uniformities in the cosmic black body radiation into the same clustering of the galaxies. And you can learn more about this, as I did, from Max Tegmark's Our Mathematical Universe. He's examined this in mathematical detail with big computers, and this just tries to illustrate. The other thing I want to point out here is that at presently and in the universe, there's still a lot of hydrogen with a little bit of helium shown here. This is hydrogen that never came together to form suns, to form stars and galaxies. This is a residual helium from the residual helium from the Big Bang. It's still and it turns out that hydrogen is the most abundant element in the universe as a whole, and about some of it fused into helium. About 25% of our universe fused into helium. And the elements that we're familiar with, the higher elements in the periodic, were forged in our stars, but they're only maybe a few percent of the total mass of the universe, or the total number of elements. So the higher elements in the periodic table were fused together in the stars. And just a reminder of how this happens in our sun. The sun is a giant ball of hydrogen, ionized hydrogen. You can see the protons. Nuclei of the hydrogen, they fuse together, and this explains it. Inside the sun, hydrogen atoms are heated so much that they turn into a plasma state where electrons no longer orbit the protons in the atom's nuclei. The freed nuclei then fuse to form helium, and you see helium has 2 protons and 2 neutrons. This fusion process releases vast amounts of energy, and this fusion process continues on to make the higher elements in the periodic table. So how does this fit into the original origin of the universe? Well, as I said, it started at a Big Bang. There were quantum fluctuations which got amplified to maybe to form those variation, the black body radiation, a period of very fast expansion, first proposed by the cosmologist Alan Guth, and here we have the protons being formed as the universe cooled, and right here nuclear fusion started, and there was a period here where the nuclei, the protons were fused into helium, helium during this period from 0.01 second to 3 minutes. And that's a measure of the temperature, another check on the temperature, because we know this fusion takes place at about 1 million degrees in our sun. So that's this way of calibrating the temperatures, another independent calibration of, in the early universe. So we have measured, as I said, the 0.75 hydrogen and about in our universe. Astronomers have measured that. And the sun fuses hydrogen to helium at temperatures at millions of degrees. So the temperatures from 0.01 to 67 were millions of degrees. And Peebles' landmark cold dark matter theory has been empirically verified after 1 second. So we have precision cosmology after about this point with predictions. When Alan Guth was asked on this program, Closer to the Truth, was asked, well, just a note about MIT Professor Guth. He was the one who proposed this inflationary period. He solved some problems in the original Big Bang beginning by his rapid inflationary expansion. And when Guth was recently asked what was there at the beginning, he replied, the laws of physics existed before any universe. So it was the laws of physics were there at the beginning. And this reminds me of the first chapter of John. In the beginning was the word, or logos in the original Greek. Greek is a logical structure, a cosmic blueprint, or the laws of physics. And the word was God, and the word was with God. This astronomer, Jastrow, put it this way. For the scientist who has lived by the faith of the power of reason, the story ends like a bad dream. He has scaled the mountains of the highest peak. He has pulled himself over the final rock, and he's greeted by a band of theologians who've been there waiting all those centuries. And of course, the worst of those was the theologian who wrote the Gospel of John in about the 1st century. Well, this contrasts with atheistic Professor Laurence Krauss, author of the best-selling book, A Universe from Nothing. This book got my attention since I was just wondering about this. It was a best-selling book, and he's a very engaging speaker, and over 2 million people have viewed his YouTube video based on that book, and that Krauss presented at Richard Dawkins' Atheist Symposium. Well, this is the best-selling book, but I have learned from listening to his lecture and from his book that for physics, nothing, well, the way Krauss put it, for physicists, nothing is not nothing anymore. For physics, nothing is an area of space with no particles and no radiation, and yet there's something there, and that something there is the quantum vacuum of virtual particles that pop out of existence and into existence and out of existence. There are fluctuations. So nothingness is a quantum vacuum which consists of these particles, virtual particles. And then I'll explain to you another aspect of our universe, that it has zero net energy. So this provocative title may have sold books, but it isn't very accurate, because for physics, quantum vacuum is not nothing. And Lemaitre and Guth, of course, their whole cosmology is based on something at the beginning. Lemaitre was hot primeval radiation singularity. Well, this is an explanation. Here's Alan Guth explaining his concept that after the beginning, there was zero net energy. Well, it turns out the gravity has the property that when it expands, its potential energy is inversely proportional to the distance. So as the universe expands, the gravitational energy decreases, as shown here. It's negative. And this decrease provides the positive energy needed to create matter. Remember, we showed matter condensing out of the hot radiation. And this is Einstein's famous equivalence of mass and energy equation. And and the two together, according to Guth, he's calculated in more detail. I'm trusting him that basically the two cancel each other, and then so the net energy of our expanding unit is zero. which solves the problem of where did that energy come from? There is no net energy. Well, here is an example of the fine-tuned expansion of our universe and our early universe. This is comes from solutions of Einstein general relativity, and they fall into three possible cases. A closed universe shown here. This is the matter density is so large that as the universe expands, gravity takes over and stops the expansion, starts pulling the universe back together, and the universe contracts as shown here. The universe gets smaller and back and forms a big crunch. In other words, one possibility for long-term possibility allowed by Einstein's relativity is the universe ends in a big crunch, or that we could fry, as sometimes verbalized as fry. But our present universe, our present understanding the present universe is the intermediate case where the universe expands, keeps on expanding forever, It slows down, the stars burn out, and we would freeze, and we freeze. That's the prediction. But that would occur billions of years from now. And then the other solution is an open universe. Now, this is where the universe is expanding so fast that the stars, the gravity doesn't have a chance to pull the stars, pull the matter of the universe together, and just everything flies apart and there would be no universe. So, and it turns out that the accuracy of this expansion, is as accurate to a part in 10 to the 17th. It's extremely, so how did we get such a fine-tuned rate of expansion? If it hadn't been, it had expanded at a very special rate, either we would have fried in a big crunch, or we would have frozen, because everything would have fallen apart. So the universe, if the universe expanded faster, stars would not have formed. If slower, the universe would have collapsed. No stars and no life of any kind. Another observation is that if the fundamental properties of the fundamental particles, if the mass were different, or if the mass of the electron, the proton different, also we wouldn't have a universe as we now see it. So what are the possibilities here? Well, let me and it's basically the Guth's explanation. I'll talk about Krauss's explanation, is that we're here because our universe is one of many possible multi-universes with different properties, and our universe is the one that has the special property for life to emerge, the very special, fine-tuned, anthropomorphic principle, and there's no God is needed. That's why he's an atheist. However, let's talk about some theory here. In 1981, Guth and Lindy's, their inflationary process, that caused that inflationary rapid expansion in the beginning, could have created many universes, namely multi-universes, in a sense with different constants, one of which was the one that gave rise to our universe. And as Tegmark once put it, inflation is a gift that keeps on giving new universes, keeps creating new universes. They keep just creating new and new bubble universes. However, a more recent paper, theoretical paper by Coley and Haslam, concluded that the existence of many universes is still very much an open question that will require much deeper investigation. So they don't buy this multi-universe hypothesis, and neither does George Ellis. Some of you may be familiar, who's written some books on science and religion. He was he did some research with Stephen Hawking. So he doesn't believe in multi-universes. So theorists don't agree and whether there are multi-universes. And Nobel laureate Phil Peebles, author of this the Cosmology Century, he's a Nobel laureate, a recent Nobel laureate, and he was asked about the existence of the multi-universe. His answer was children's fairy tales. So he obviously doesn't believe in them. because they're only they're hypothetical, and even the theorists don't agree that whether they're there or not. So that sort of maybe challenges Krauss's idea that he doesn't need a God for fine tuning. But there's another critique of this book was by a philosopher of science at the New York Times, who said, his name is Albert. He claimed that Krauss dismissed concerns about Krauss's misuse of the term nothing, since, and they said nothing is really the relativistic quantum fields, and he doesn't answer that question as to where those fields come from. So that's another critique of a universe from nothing. And although it's very engaging and it was a bestseller, very well written for the and Krauss is a popularizer of science, as is Richard Dawkins. So something at the beginning. Well, I'm going back to cosmologist Alan Guth, who was, when asked what was there at the beginning, he said the laws of physics existed before any universe. And for me, this is reminiscent of John 1:1. At the beginning was the word, or logos, and the original Greek logos is a rational, logical structure, a cosmic blueprint for the laws of physics. And the word was God, and the word was with God. So in summary, I've told you, given you an idea how our vision of the universe has expanded from our knowledge about the Milky Way, which has a radius of 1/10 million light years. In 1927, Lemaitre's proposal, Big Bang theory, and the discovery of that cool fossil microwave radiation of the Big Bang that occurred 13 billion years ago. The Hubble, I've shown you the Hubble telescope images of galaxies 2 billion years after the beginning. I just mentioned Alan Guth believes that the laws of physics existed before any universe. And finally, the James Webb Space Telescope images of galaxies that were just taken a few months, where we've been able to see galaxies 0.35 billion years after the beginning, much earlier. And well, as our knowledge island expands, so does its shoreline with mystery. And there's still many, as we've learned a great deal in the last century, there's still many open questions. My knowledge expanded on this island, and I have my wife here. Do you recognize this aerial view of this island? What island is this, Jenny?
Oh, it's beautiful Star Island.
Well,
it's a gorgeous place to be.
Yes, and I must say we've enjoyed our knowledge has expanded while attending IRAS conferences since 1995. I actually attended one in 1969 when Margaret Mead came, but I've been going to conferences every year since 1995. Star Island off the ports of New Hampshire, site of the upcoming IRAS conference, the Wizards of Climate Change, the end of June, and you can learn more on our webpage. As a final discussion question, which I'm going to pose to Ginny, and maybe my responder will weigh in, and I'd like to encourage you to weigh in on this. Physicist Krauss believed in many universes, multi-universes, but I'm asking the question now, which requires more faith? A definition of faith is the assurance of what we hope for and the certainty of what we do not see. And we certainly have not seen any evidence of these multi-universes. So the first option as to what requires more faith would be multi-universes that have not been observed to date and about which theorists do not agree, and are likely to be discovered in the near future. And if they don't exist, we really need, I believe Krauss is in trouble, deep trouble. And unfortunately, he and I have phrased the second option in terms of process theologian like Tom Oord, an eternal creating process, which is part of God's nature, with an earth, with living cells first, then dinosaurs, mammals, and humans. So there are other possibilities that you might think of. I've thought of some myself. But Jenny, what's your take as to which requires the most faith right at the present time?
Oh, I think for me, it would be number one, that there are multi-universes that have not been observed to date.
Not observed to date, and which theorists do not. I might say one of the problem I have a personal. I've read Dawkins' the God Delusion, where he's very critical of religion and and by the way, Krauss is not very polite about his view of religion. Is basically biblical literalists who take the Bible literally. That's his. He is unfortunate. Neither Guth nor they're very sophisticated in their science, but they're not up on the latest process theology, which started with a mathematician and philosopher Alfred North Whitehead, a fellow Englishman that particularly they should know about. And I won't go further into that, but I agree with Jenny right now. But I think if multi universes, I think his faith is challenged. If these multi universes, they certainly haven't been proved to exist, and if it turns out they definitively don't exist, maybe he should look into maybe he should have a look at Whitehead, which he and Dawkins do not understand. And not familiar with it, which is a disappointment particularly for a Oxford University professor to write a book, the God Delusion, which has absolutely no knowledge of an English philosopher, mathematician Alfred North Whitehead, the father of the origin of modern process theology. So, well, maybe I should remind myself. Maybe I should be a little more humble. Maybe I didn't set a very good sample, but we should try to get it right, which I do. I do try to get it right, but rather than being right. So I hope I didn't come across of trying to be too right. But another reminder that comes to mind, which I can illustrate this saying that progress in physics occurs funeral by funeral, and I've given you an example of that in my talk. Fred Hoyle never believed he had his own steady state cosmology, and he never believed the whispering Eunice Big Bang cosmology till his dying day. So that's an example of an eminent astronomer who's made a significant contribution, who has passed away, and we have people like Alan Guth, the next generation, who are building on and answering new questions. So I think that's it. I think we'll turn it. I'd like to turn it over to my respondent.
Hey, Paul, thank you very much. This was really a great talk. And I want to remind the audience that you can submit your questions in the Q&A box. I already have a few that have come in. But with that, we'll turn to our respondent here, who's Dr. Christopher Corbally. He's a Jesuit priest and astronomer with the Vatican Observatory Research Group. He's been the vice director there. He's the liaison to the headquarters at the Castello Gandolfo. He is an adjunct associate professor in the Department of Astronomy at the University of Arizona. And he has a history with IRAS. He was president of IRAS from 1999 to 2002 and is co-founder of the Human Science Project. Chris, let me turn it over to you and let you go from here.
Thanks very much, Gail. Yeah, just Human Sentience Project. Science is definitely very much part of that as well. Oh, this was wonderful. I'm so glad how it built on what Thomas laid a beautiful foundation account last February, and also that Thomas Oord is also present, in our gathering at the moment with the participants. A beautiful account of God as ever creator, but still, as he presented this, and particularly the points that countering creation from nothing, I got a bit uncomfortable. And I suppose Paul Carr has equally beautifully removed a lot of my discomfort and points out there are always will be gaps in this vast cosmic universe. So, let's try getting it right rather than the being right. So let me say, just present where I come from. My dominant thought is that creation is God's action of creating a relationship with the created, a relationship which becomes ongoing through continuous providence. It's actually got nothing to do with nothing. Let's explain a bit. I come to this by going back to St. Augustine, wonderful thinker. We're just celebrating today St. Ambrose, who baptized St. Augustine. And Augustine's understanding of the nature of time as a measure of change. I agree with Augustine that creation marked the beginning of time, since time and space-time involves things changing. Before that, there wasn't time, before creation. So asking what was before creation makes no sense. Indeed, Augustine himself denied that he joked about what God was doing before creation. You'll remember the thing, he was meant to be asked, what was God doing before creation? And God was saying, God said, well, I was making hell for all those who ask those kind of questions. Well, you've heard that, it's wonderful. But actually, Augustine said, yeah, I didn't say that. What I do say, and it's a much more profound answer, is that I do not know. God certainly was not getting involved with any nothing of quantum physical vacuum. So, in the beginning, that's the phrase that begins Genesis chapter 1, verse 1. And that in the beginning is not a time concept, but following the root sense of the Hebrew word beginning reshith, meaning head or origin, then it's saying that God is the source of heaven and earth. Similarly, as Paul Carr pointed out, the beginning of John's Gospel says, in the beginning was the Word. And this beginning is the Greek arche, en-arche, in the beginning. And that's concerns which no temporal statement can be made. That's arche, beginning. So God is source and origin both of creation and of its and our, obviously, future. So this origin of the universe is of a different order than the physical nothing skillfully described by Laurence Krauss and, yes, echoed by Richard Dawkins, those good neo-atheists. And to understand this different order, I've turned to William Steger, a Jesuit who until his death was part of our Vatican Observatory. He's cosmologist and very much at home, along with Stephen Hawkins, with black holes and quantum vacuums and wave functions of the universe. And what I call him Bill Steger, points out is that the primary origin is the necessary condition for all these black holes, quantum vacuums, and wave functions of the universe. And so our cosmos, to exist, has this necessary condition, a primary origin. And it's true even of the laws which these physical entities follow. So creation from nothing is not about an origin, and certainly not one in time, which is the realm of the changing, but it's a relationship which everything that exists has with the Creator. The creator doesn't control creation, as Thomas Oord well expressed, but enables it and empowers it to be what it is. And it follows its appropriate freedoms according to the laws that are there of the universe that apply specifically to it. This origin or enabler of being and ordered activity is both outside of any physical action by an organism or system, person, and process. This being outside is what is traditionally called transcendence. And yet, this origin enabler also evokes the response of all these to their environment, to everything about them and what they are in themselves. And so to their origin, maybe with a capital O. And this is, I think, what we mean by immanence. I'd like to say, in summary, that this understanding of origin outside of time, or creatio ex nihilo, does not compete with physical cosmology, explained beautifully by Paul Carr, and natural explanations of anything emergent in the universe, so biological evolution. It certainly complements the scientific description as a consonant level of understanding reality. It helps to make the whole picture. Thank you. Paul, I think you may have got my questions a little bit as well. Yeah. So does it matter that there's a beginning?
Pardon?
It doesn't matter there was a beginning.
Anyway, take it on.
Does it matter? Was there a beginning? Does it matter? Well, as I said, as you say, in our modern cosmology, there was a beginning. So in Lemaitre, there was a hot Big Bang, and Alan Guth, I haven't gone into it, but he has in the beginning, he thinks there was maybe a special kind of matter with which has anti-gravity, an explosive gravity that it caused the expansion, something like that. So in modern cosmology, there is a beginning, but I doubt if we're ever going to be able to measure it directly. At least we've been able to measure back to about, 380,000 years after the beginning, and there is a sequence. And as you can see, I'm quite intrigued by the fact that Hubble gave us enabled us to visualize galaxies 2 billion years after the beginning, and now the James Webb has given us some galaxies that are much closer to the beginning. So there is modern cosmology does have a sequence.
No, very much so. But I was also explaining how beginning has another meaning, which is in philosophy and theology. So the scientific, yes, I understand, and you beautifully expressed.
Right, but also getting back to some the Book of Revelation, the Book of Revelation state, God says, "I am the Alpha and the Omega. I am in the beginning and I am in the end." So there's a statement that of God being present at the beginning of time for us, or for our universe, and then he will be present at the end.
I think what we're saying is that beginning, like creation, has many meanings.
Yeah, good point. Now, that's a good point. That's a good, particularly when you consider the philosophy, the philosophy, and as you point out, that the root meaning of a lot of these words is amplifies our worldview, complements our worldview, and gives us a much deeper understanding. Yes,
lovely, beautiful.
Mm-hmm.
Well,
we agree.
Thanks to you all, to you both. This was really great, two great talks and great discussion afterwards. I think I'm gonna, start to take some of the Q&A that are coming in, and I want to encourage our audience to please enter any questions you have in the Q&A box. The chat is disabled, so you can't use that, so please put in the Q&A. And the first thing I'll do, Paul, is read a compliment to you. Thank you, Paul. You are an incredible facilitator. Much gratitude for this presentation, and it's entered by Diane Bianchetta.
Well, thank you, thank you, thank you.
Okay, so let me go to the first question. You didn't mention Teilhard. Does he have anything to add to this discussion?
Oh yes, thank you, thank you. I was thinking of including that, but I didn't want to go too long. But Teilhard envisions the universe as not ending in a freeze. He envisions the universe. Well, first, remember, he is a paleontologist and a geologist, and he said the universe, or at least the universe as we know it, or the Earth as we know it, started as a geosphere, and then then an atmosphere, and now now that the humans dominate the Earth, he called it a noosphere, basically a cultural, symbolized really by the internet. So he envisioned a progression toward greater spirituality. And he envisioned the end of the universe as converging. For him, the evolutionary history of Earth converges in what he calls an omega point, which is his symbol for God. Remember, I mentioned God being in the alpha, in the beginning, and in the end. So he basically he basically envisions the directionality of the universe of increasing spirituality and converging in us being more spiritual, basically. So and it is interesting that it always intrigues me that one of the fundamental constants in cosmology that doesn't have a chance is called omega. It's and the value of omega, which is the ratio of a state. Well, it's a little hard to define, but one of the key parameters in modern cosmology is omega. But omega for a cosmologist like Guth is quite different from Teilhard Chardin's omega point, and he envisions the universe as converging toward in a spiritual omega point as our spirituality increases and develops. So that's my understanding of Teilhard. His end of the universe is definitely not freeze.
Thanks, Paul. Let's move on to the next question. Thanks for your good presentation. I've read that there is more dark energy matter in the universe than can be accounted for at the Big Bang. Torok and Steinhardt appeal to this excess in their cyclical universe theory. Do you know where this thinking is moving today?
I guess I'm not that familiar with. I didn't mention it, but I had a backup slide, but I didn't show. But basically, it turns out that our galaxies do not have enough. The gravity of the visual matter in our galaxies, which are rotating, the visual matter does not have enough gravity to hold it together. Centrifugal force would tear them apart. So astronomers hypothesize the existence of dark matter, which has gravity, and it's generally thought of weakly interacting particles, but it's called cold dark matter. And this is a very important parameter in present-day cosmology. Present-day cosmology, in rough numbers, dark matter is about maybe 30% of our universe. Remember the equivalence of mass and energy, and dark energy, which is that a repulsive force which is driving the universe apart, is like 70%, and the baryon, the matter of our Earth that we're familiar with, with the nuclei and so forth, is only 5% of the universe. So that's just and we don't really understand. Well, people think we're on the verge of discovering what dark matter is, but understanding dark energy, which is the predominant energy in the universe, that's part of the mystery that is a challenge for next generation cosmologists and for physics.
Great, thanks, Paul. I'm going to take the moderator's prerogative and ask a question, and I'm going to pull Chris in for this question as well. I want both of you to answer it, or I want to hear comments on it. So the question is, there was a Russian theologian named Sergey Bulgakov, and he talked a lot about creation in his work. And he argued strongly against the use of Augustine's thinking about causality, and said that when something is caused, you can actually cause something to happen. You can do something and that makes it happen. But he said creativity is not like that. Creativity, it just comes. It just comes when it wants. And he believed that the word creator was very specific for God, that word should be used and not causer, and that creation should not be talked about as being caused. But then he went further to say that with creator being sort of an eternal name for God, was there ever a time when God was not creator? And he argues that that there's not. That while you can talk about beginning in a timely sense, the creation is out of eternity. And so it kind of argues that point that Chris was bringing up, that there is time and there is eternity in a way. And I guess I'd like to hear your thoughts on that thinking of Bulgakov. Either one of you.
Paul, yeah.
Well, there's another. There was just a quick comment on causality. You know, there's a saying in science: correlation is not causality. That's in other words, there has to be a physical law that causes A to go to B. You know, that there has to be that would be causality. But there was also a Scotch skeptical philosopher, I don't remember his name right, who said, well, you know, causality is really the fact that A follows B. He was very skeptical. He said it wasn't necessarily a relationship, what we call causality, that, you know, of course we turn up our thermostat and it gets warm. And we scientists know exactly what's happened, but he would be even more critical. He would say, well, it might not be that way. It's just that, you know, we scientists have a physical reason for why when you turn up the thermostat, it gets warm. But I think he would be more skeptical and say, well, that's just the way things happen. Isn't necessarily caused by anything. So he's critical, but I don't know if that I don't ascribe to that. I don't. Do you have any comments?
Yes, thanks indeed, Paul. Ever creator doesn't. It's appealing. I agreed, and I'm not. You know, it could well be. I can't say yes or no. A bit like Augustine, I would say I don't know. Certainly, I don't feel that God has to be. There's any compulsion in God to be ever creator, because God as just pure act, that the act of God is love, and for me the doctrine of the Trinity is infinite love. It's totally sufficient love for God as love, and yet there's also that sense that love's always expanding. So, and hence we can think of creation as that sort of expansion of God's love into matter. Amazing thing that's matter. So, again, I rather like Augustine. What was God doing before creation? I don't know. I really don't. But ever creator, yeah, that would be fine, because I don't think, again, time, our time, our change of its time, even if you think of the 4 dimensions as well of quantum, space time. That that's changing. So it's of a different kind than of God. But with God, again, you have to hold a tension between two things. It's always transcendence and immanence. And if you lose either of those, I find you lose God. And the same with, the eternity of God, which Augustine would say is not changing, and yet also the time in which God, through immanence, is involved. So if you have a God that's not a God doesn't have these ideas in tension, I feel you don't have God or creator at all. You've missed it. And so that's why I joined Augustine in saying, I don't know, because don't ask me to imagine the paradox. Hopefully one day we'll all know and enjoy it.
Well, thank you both. There's another question here. It looks like it could be for either of you. So maybe, Chris, you should stay on. An insight from Aquinas on what God was doing before creation is this, quote, sheer joy is God's and this demands championship, unquote. So God was swimming in joy and invited all of creation to join him or her. What do you think of that? And Eckhart says, regarding beginning, God is always in the beginning, and that is why Genesis 1 and John 1 begin with that. But to be always in the beginning is to be I don't know this word, novissimus, the youngest thing there is. What do you say to that? Thank you. I think either one of you can answer, or both of you can answer, maybe.
I think maybe that's more for Chris than for me.
Matthew, I think you've got some wonderful thoughts there. Yeah, if joy is not associated with love, then it can't be love, in my thoughts. So, that insight from Aquinas, sheer joy is God's, and this demands companionship. Yes, and the companionship is in, with due deference for Unitarians among us, the companionship I see in God is the Trinity, which we call persons, but that's inadequate. But that's the companionship of God, the fundamental relationshipingness of God is there, and that's the source of the joy. Creation, matter stuff that we're involved is a kind of a spilling over, I feel, of that joy, love within God as a relationship, which I call the Trinity. So that's the first part. Should we take Matthew's second part, or would you like?
I think so. I think we should take the second part, unless Paul wants to step in and answer.
No, I don't want to step in.
Okay, so Chris, why don't you go after the second part?
God is, Eckhart says about the beginning, God is always in the beginning, and that is why Genesis 1, begins with that, in the beginning, always in the beginning. Yes, God as, pure act, that's always beginning. I see no problem with that. Of God always being the most new, the novissimus, the most new. Yes, because God is not a static idea. God is dynamic. God is act. Beautiful.
Right. I agree. Yes.
Great. And Matthew says, I see creation as companionship too, and your word relationship, sharing the joy celebration goes with it. So he's obviously agreeing with you. I'm not seeing any other questions in the Q&A box. I see Maynard lighting up, so I think he has a question. Maynard, please.
Well, I'd like to pick up on a couple of the things that have already been mentioned. Tom Oord's original question today is important for us to remember, because it connects with one of the things that Christopher said in his initial response. Chris, you used the word relationship as essential in this understanding, and Matthew Fox uses the word companionship. It's a similar kind of concept, and relation means something, not nothing. You cannot have a relationship with nothing. You can only have a relationship with something, or in Christian terminology, it's someone. We have a personal concept of God, so that, but it's one and the same. The relationship is with the one who creates, and that is essential, because that is part of what Teilhard makes so clear in all of his writing, and it's consistent with what Whitehead and Hartshorne say about a relationship that with God. But this is inherent to God's nature, is to be in relationship, and we call that love. So that has to be recognized throughout this discussion, that relationship is actually the manifestation of what you have been talking about as creation.
Beautifully put. I think these, again, all seem to be complementary ways of trying to approach this thing that we call God. A simple word, but so beautiful and beyond our current understanding. And yet, you know, the signs, as it were, the fingerprints of God are all there through what Paul was talking about with the cosmology. And so that's the beautiful thing as well, the relationship of God that can be seen in creation and through all this amazing story of cosmology.
Yeah, I think of a relationship, God being in relationship, that God as sustaining the laws of nature. They don't change, and that's when God also sustains the creation as well as relating to it. And also, I think there's a term which I've heard in process thought called panpsychism, that everything, even atoms, have a degree of sentience, or like, atoms obey certain laws, but there's a small amount of volition, or even in particles or rocks, or that God is in relationship. But when you say God is in relationship with all creation, generally we think of in relationship with people, with humans, because that's obviously most meaningful to us. But I think there's also an aspect of God being in relationship with the material world, first making sure that it obeys consistent laws. That's otherwise we wouldn't have science if the laws of nature kept changing. So that he does sustain the laws of nature as part of that relationship.
Yeah, much so. Tyre, who could see the activity in a stone, that a stone is not inert.
Yes,
but
yes,
stone
yes.
is dynamic, and I think that's also what you're talking about.
Yes, for geologists, that's right. Mountains are not static. Of course, the Old Testament tends to look at mountains as being eternal, but remember tectonic plate theory of geologists. That basically the mountain ranges, like say the Rocky Mountains, were created by two tectonic plates colliding and pushing up pushing up the mountain. So that but the timescales for geology are millions to maybe even billions of years.
So there's one more at least one more question. But I think this will be the last question unless somebody else pops something up. And I think it's for both of you again. What could be the position of Paul Tillich on the topic?
Oh well, that's since Chris brought up the issue of time for Tillich. There are two kinds of time for Tillich. One is major milestones. I guess he calls it kairos time, which is a word for crisis, but they're major events. And I gave, for example, in Cosmology Century, I gave you some major events, which would be kairos events. And of course, in our personal life, it would be maybe when we were born, when we were married, you know, something like that, when our children were born. So they're the kairos events. But then, but then there's also chronological time. His idea of chronological time is the time, sort of time that science uses. So the chronological time is what we measure with a clock, and but human time, time consists of both kairos, major milestones, as well as, and of course we measure our days. And by the way, you know, our chronological time is key to the cosmos. Our year is the time that it takes the Earth to travel around the sun, and then the month is basically the cycles of the moon. But it is interesting that if you think about it, our second is basically a heartbeat. 1 second. I mean, well, I think my Apple Watch tells me my heartbeat, but depending on how active. But 60 heartbeats a second it can be a normal human heart rate, and that's and another issue with regard to time is where do we get our 7-day week? Why is it? I mean, you know, I told you this cosmology. Where do we get? And it's apparently it came out of the Mesopotamian Babylonian culture. They had a 7-day week, and which is symbolized in the first chapter of Genesis. God created the world in 7 days, or 7 epochs. Turns out the Egyptians had a 10-day week, just by contrast. So that's the reason for. Tillich also looks at creation as continuing, not something that happened at the beginning, as creation is the continual activity of God. And Tillich looks at the creation, and God is the ground of all being, the source of all existence. These are some comments about Tillich, and I think he would agree with Augustine about that there was no time before the beginning of the universe. There was no time.
Great, thanks, Paul. I mean, Chris, do you want to comment here too?
Yeah, well, Paul's very much up on Tillich, and I love that explanation. But I understand from Augustine was content with the idea of no temporal beginning of the universe. But beginning as far as origin and God, yes, you know. So I seem to remember Bill Steger talking about that, but I hadn't found that passage myself. So yeah, you're absolutely right about that. I love the, if I may take from the contribution, Matthew Fox comes back about our stones. Yeah, Hildegard of Bingen saying, every creature has an interior life. Stones are creatures too. How wonderful.
Yes, I think we agree.
Well, I guess that's a wonderful note for us to end this session on. I want to thank you both, Paul and Chris, for really giving us an enlightening session. It was delightful. Many comments have said what a great job it was. I learned a lot from you. Thank you so much. I'm sure people are at least applauding in their hearts right now.